Hey everyone, James here from Mortisk Media, and we are back with some more Unreal Engine 5 tutorials. And in today's video, we're going to be looking at something I talked about briefly in a previous video when we were looking at blueprint interfaces. What we're going to be talking about is today's line traces, and the different ways to use them, and different ways that you can set them up, to be able to better utilize within your game. So without further ado, let's go ahead and jump into it. So I do have a clean project set up here, so that way we can, kind of work out of something without all the previous tutorial stuff that we've done. And we will be going back into that project eventually. Just for some of this bigger stuff, I wanted to get a clean project, for the purposes of showing you guys what to do. All right, so let's start with a couple of basics, like what is a line trace? Well, a line trace is realistically exactly like it sounds. It's a line that's being traced from point A to point B, and you can give it those parameters of where to start, how far to go, the angle to go from, all of that good stuff. You can also, what's going to happen is between the line traces, if it interacts with something, so if something is in its way between its starting point and its designated ending point, you can get information about the object that it hit. And there's so many things you can do. Line traces are by no definition a one-trick pony. And this is why this video might go a little bit longer. I'm going to try to keep it concise, but there's so much to cover, so I'm going to try to keep it as minimal as possible. But we'll see what happens. Now, to show you how to be able to set up a line trace, first thing is we need to go into our blueprint, our character blueprint. So for me, that's the third person character blueprint under third person blueprints BP third person character. And then we're going to pull up our event graph here. Whoops, that was not what I meant to do. Event graph. All right, so now we are going to be using event tick for the purposes of this video. However, I do want to say that you can use event tick for a few different things that like as far as like line traces go. You can have a few of them that are running. However, you do not want to have 80 of them running off of an event tick. It will cause your system to overload. So just make sure that if you're using event tick within your game as your product, you're keeping it, within a reasonable limit. Also, if you just saw me delete booleans, don't worry. That was just from a previous time that I recorded this video. We're going on a few times now just to, so you guys know what happened there. So what we're going to do, though, is off of event tick, now we're going to take a look at the types of traces. So we'll go event tick, drag off, and trace. Now, under collision is mainly what we want. So we're going to scroll up a little bit here and collision. Now, as you can see, we have box trace, capsule trace, line trace, multi versions of this, so like multi-line, multi-capsule, multi-sphere, and then the standard sphere. Now, we also have trace by channel, profile, and then components, and then objects. What we're going to mainly focusing on is the standard trace by channel trace panel. So we're not going to be using multi-sphere or multi-line, and we're not going to be using by profile. We're just going to do line trace by channel is actually going to be the first one we'll start with. So we'll start with line trace by channel. I just wanted to show you guys all the different options when it comes to channels and line traces, because there is a lot. So now if you look here, you'll see there's a start position, end position, and a whole bunch of information down here, over here. Don't worry about either of those points. We'll just focus on the start and end point right now. So the first thing we're going to want to do is we're going to run a right click and then type in get actor location. So what we're going to do is we're going to start up with a very simple trace of just kind of getting it to go from the character and forward. So we're going to get actor location, and then we're going to get actor rotation. And also from get actor rotation off of the return value, we're going to do a couple of more notes here. So we're going to get forward vector. And then off we get forward vector, we're just going to add a multiply node. And then on this multiply node, we do have to change something here. So we're going to right click on the B vector pin here. We're going to convert it to a float single precision. And then just set it to a value like 250. All right, so this is basically most of the nodes you're going to need. We're going to need one more to be able to make this work together. But what we're going to do is we're going to get on the get actor location return value. We'll take this and plug this into the start point. Now we're also going to, off of the get actor location return value, we're going to drag off of it again, and we're going to put in an add node. And then we're going to add this and this multiplication. So this return value vector here, we're going to plug this into the bottom section just like so. And then this little output here for that add is going to go into the endpoint. So just to give you a brief understanding as to what's happening here is we're getting the actor's location, and then we're using that as our start point. And then for our end point, we want to get the actor's location, but we also want to get the actor's rotation to make sure that it's always going in the forward direction of our character. And then we're going to multiply that by 250 units. So this number here actually represents the trace distance. So you can actually take this, right click, and promote it to a variable. And we'll do trace distance. So this way we can have it as a usable variable that we can then reset based off of this, rather than having, like, if we're all the way over here in our graph, we don't have to like go off and find it. You can then just set it based off of the variable valuable. So it's a lot, or variable value. So what we're going to do now though is if we go compile, save, and then play, you'll see that there is now, oh, actually I apologize, we forgot to do one more thing. So we're going to go back to the line trace, and we need to change the draw debug type. So when you go change it from none to for duration, and compile and save. So now if we go and click play, you'll see, there we go. So now we have our line coming from kind of like the pelvis area of our character. Now the reason why it comes from that location particularly is because if we open up the viewport here and we look at our character, you'll see, oh, we got a little extra item in there. We'll take that out of there. You'll see that this blue arrow here, don't mind the red arrow, you'll see this blue arrow is right where that line is starting. This is going to be, technically speaking, the actor's origin point. Not up here, not down here, not this whole thing, just right here. So this is also going to be correlating the direction. So for that rotation that we have, it's going to be this forward direction. So that's how it's calculating it based off of the actor value. Now, let's say you want to get it from, instead of going in forward direction, what if we wanted to have it go from the left or the right? Trace for walls or something next to the character. Well, so how you would do that, we'll start off with the right side. So from get actor rotation, we keep everything else the same. But from the actor rotation, we're going to drag off and we'll get right vector. And then we'll take this return value and plug this in back into our multiply node. Because if we now compile, then play, there we go, you'll see now it's coming from the right side of our character. So we can go ahead and just, run up to a wall and it will detect the wall. So it's very, very cool. Now, one thing just to show you guys as well, if I can get the angle right, is you'll see it starts off red, then goes into a little red box, and then it kind of goes green. So what that is it's telling you, like, hey, red is indicating, like, hey, we're going off and trying to touch something. The box indicates, hey, we've touched it. And the green is like, nah, bro, we're done. So that's really all that is. You got red that indicates that we're going out and tracing for something. The box that is indicating the hit for that trace. And then the green just indicating, like, we're not going to do anything else after this. This is where multi-traces come into play. And you can trace for multiple objects rather than just a single object. That's what a multi-trace is. So if you guys wanted to trace multiple things, you would do the same thing that I'm showing you today. Just use a multi rather than the single, line trace by channel or whatever. All right, so that's the right side, but how do we get the left side? And, you might think that if we just go off of the rotation, get left vector. Well, nothing shows up. Turn off context sensitive, still nothing shows up. So how do we get the left vector? Well, we're going to pull back in the get right vector. We'll pull this back a little bit. Pull this forward. And then off of the return value of the right vector, we're going to add a multiply node. And just like what we did for this one, we're going to convert this pin to a float single precision. And we're going to multiply it by -1. And then we'll take this return value, plug it into the other multiply node, and then if we compile and hit play, now it's going from the left side. Because what we've done is we've taken its right vector, multiplied it by -1, so this way we can get the opposite of the right vector, which would be the left vector, and then telling it to take that trace distance value, push it out that far from the actor's location, all that good stuff. So this is basically what's happening is we're getting the location, and then if you want the right vector, you just got to multiply it by, or the left vector, you just got to take the right vector, multiply it by -1. Now the same thing applies if you wanted to get something from, like a trace going from behind the character. You would just get forward vector, and then plug the return value of that into that multiply at the top there. Now if we compile and then hit play, keeping everything the same, again, now we have the trace coming from behind the character, or going behind the character rather than in front. So using that multiply by -1, we can get the opposite of whatever value that is preset, which is realistically just the forward and right vectors. So now another thing I want to show you guys is like, what if you don't want to go off of that actor's location point? What if you want, like this point here, if you wanted to go somewhere, like along the foot, which is why that you saw that red arrow earlier, is because I was just doing some testing and as well as from redoing videos. So I do apologize that that was still in there. But what we're going to do is we're going to delete the get actor rotation and location. And then we're going to go to the viewport here, go to our components, and we're going to highlight the mesh and then click add, then type in arrow. This way it'll add an arrow component parented to the mesh. And then we're going to take the arrow component, we'll rotate it so this way it is facing the same direction as our character. And then we're also going to go ahead and drag it up right about there, right along the foot area. Now, the reason I like to use arrows for this is because it gives you that directionality. This is going to be the direction it's facing, right? So this is its forward direction. I don't have to worry about like, oh, is this its forward direction? I'm not really sure. That is 100% its forward direction. So then, because what we can do is drag the arrow in, get world location, and get world rotation. And then we'll take these and plug these back in. So we'll take the world location, plug this into the start, and then again back into the add node. So this way we have, everything hooked up exactly the same way we did before. The only difference is that rather than getting the actor's location and rotation, we're getting the rotation and location of that arrow that is then parented to the mesh. So if I compile and play, you'll see, and because we still have the -1 hooked up to it, it's going behind the character, but it's pushing off from the foot area rather than the middle of the torso. So, and I can easily just go ahead and just take out that -1 multiply, hook this back up, compile, play, and it works exactly like it should. So, and the cool thing about this too is that you can set up angles through mathematical functions, and sometimes it can be a bit of a pain. What I'd recommend, as long as you're not trying to set up too many trace angles, like angular traces, I guess I should say, you can actually take the arrow, and let's say if I rotate it like 40 degrees, something like that. If I compile and then play, I've changed nothing as far as the code, but now the arrow is kind of going out as almost like a 45. It's a 40-degree angle from the character. So this is a great way for you to be able to really control the angle at which something can go. So like you don't necessarily have to do the right vector, left vector. You can just take the forward vector of this, face it to the right, and then just do a negative multiply on the other side if you wanted to get like left and right. But this is more just really for if you're trying to do like a 45-degree angle, or you really don't know the exact angle and it's really just a lot of trial and error. This is the easiest way to at least identify the angle. Then from there, you can set the angle's position within the code itself, however you want. But this is a great way to get like exactly the way you need it to be. Now, speaking of getting things exactly the way you need to be, one thing I do want to talk a little bit more about before we move on is going to be the trace distance. Now, trace distance, because we have it set as a variable, we can then set this number to whatever we want. So like right now it's set to 250, but if I set it to a value of 75, for example, and I've disconnected the arrow, so I gotta re-put in, so that's fine. We're just gonna get actor location, pull that up, get actor rotation. There we go. And just plug these back in like so. So that way we have kind of a reset back to where we started. But if I take that trace distance, keep it at 75, and if I go and play, minimize that, you'll see that that distance now becomes a lot shorter. So if I wanted to make it so that way, I have to be really close to the wall. I apologize about that. That's totally fine. I have to be really close to the wall. If you wanted to make it so that way you have to be very far from something, you can do that as well. But what if you wanted to have a long trace and, be able to tell it to do things based off of the distance that you are within that range. You don't necessarily want to set it to just be that range. You want to tell it to do different things based off of where in that range it's actually hitting. And this is where we start looking at the out hit results. So we're going to come back and look at trace channels in a bit, but right now I want to talk about the out hit section and the return value and the way to set these up to make them actually do things, because this is ultimately where all the magic happens. This is just telling it where to go. This is going to be where everything actually happens. So what we'll do is off of execution, we're going to type in branch, and then we're going to connect the return value here up to the condition. The return value here is essentially just a Boolean true or false if there was a hit. So if it didn't hit anything, it's going to be false. If it did interact and hit something, it's going to be true. Now what we're also going to do is there's two different ways you can do this. You can right click on the out hit result, split struct pin, and get this interface. However, because it says out hit and on everything, and it's also on this trace channel here, this is way too much going on one panel for me. So I'm going to recombine this. And then if I go out hit, break hit result, and then just kind of hit that drop down, now I have everything here. It doesn't say out hit before it, and I can also have this in its own little panel. So I prefer to do it this way, but there are two ways you can do it, so whatever works best for you. So now what I want to talk about, just because we were talking about distance, I'm going to circle back and we're going to talk a little bit more about a lot of these hit results. But I want to talk a little bit about the distance function here off of the hit result. This is exactly what I was talking about, where you can create a distance check and be able to tell exactly where we are as far as the distance from something. So if I go and hit true and then just type in print string, and then off of distance, I plug it into the in string section. If we go ahead and play, now nothing's going to play immediately. And actually, I'm going to go ahead and make that line just a little bit larger. So we're going to go to our trace distance, and we're going to set this back to 250 because that's a pretty good distance. So we'll set that and then play. Boom. All right, so now what will happen the second we interact with something, we'll start getting a distance meter. So we're 217.128525, right? And then we get closer and closer and closer and closer until we eventually get the absolute closest we can get, which seems to be about 35 units away. So what you can do, though, to be able to make this or turn this into like a distance check is you go to your blueprint, and you can make a quick Boolean variable. So we'll just set this to in range, and we'll drag this off, and we'll get a setter, and then we'll duplicate it because we're going to need two versions of this. Now, we'll also take off the print string, and we'll add that back in later. But what we're going to do, though, is we're going to take off of distance, we're going to promote this to a variable. And we're going to set this right off of the first thing we do after the true section of the branch. Now what we're also going to do is we're off of here, we're going to see if it's less. So we're going to go less, and then we're also going to add a branch here as well. And then we're going to take the condition and hook that up here. So what we're going to do now is take the distance, plug this into this value, and we're going to see, let's say, less than 120. Sure. So what this is going to do is, if it's true, if we are within a range of less than 120 units, we are going to set a Boolean of in range. If it's false, we're going to reset and make it so we are not in range. Now we also do, just because this is something more just to keep in mind when creating these types of distance checks, is that you also want to make sure off of the branch false result, plug this into the set of false on in range. The reason why you want to do this is because if you are within range of something and it's detecting it, it's just not, but you're not more than 120 units away, and then you go from detecting something to not detecting something, it's going to get stopped at this branch. It's not going to set it back. So we want to make sure just to go off of false and set the in range to false back again. And this way you'll have your constant loop of it'll only be true when you are exactly within range, within the range set. Now another way you can do this as well, you can also do off of distance, you can do in range, an in range float. Now this is really cool because you can actually set it between a min and max value. So let's say instead of, if it's 0, or instead of 0, because that's what it would be on a less than, because 0 is less than 120, we can set it to a minimum value of, let's say, 50. and then a max value of 120. And then we'll take the return value and hook that up into there. Now we're also going to do a print, actually we'll do a delay, and we'll do one on each, so this way it's not printing out so many that we can't really see what's happening. And then we'll do print string, then duplicate that, and then in range get closer. All right, so what's going to happen here, I'm going to set these to 0.5, hope not 5, 0.5, 0.5. All right, so what's going to happen is that it's going to run our trace. It's going to check and see whether or not our trace is hitting something from the point of our character to its actual hit point if it's in range between 150 and 120 units. If that is not the case, it's going to go as false, and then it's going to set in range to false. And then it's going to do a delay, and then print a string of get closer. And if it is within the range of 150 to 120 units, then it's going to go to true, set in range, and then going to just tell you that you are in range. So I'm just going to compile, save, and then I'll play so that way you guys can kind of see a little bit better. So like right now it's saying get closer because we have the print string running off of the same. So I'm actually just going to change that real quick. So rather than running off of this, we'll just take this and duplicate it. Whoops, that was not what I meant to do. Let's see, bring our event graph back up. There we go. All right, so we'll take this, duplicate it, and then we'll set this off of false. This way, it's not constantly saying get closer. It's only going to say get closer when we're actually, hitting an object. So if we go and hit play now, there we go. So now it's not saying anything until we get within range of an object. It's just constantly saying get closer. And then we get closer, and now we're in range. However, if I go all the way close, it's saying get closer. So there is a few different ways that you can go about doing this, but this is the best way I've found to be able to create a distance check. This way it allows you to be able to control where in sort of world space your character or the AI or whatever you're coding is able to interact with the world. So that's basically the distance check system with a line trace. So I'm just going to take all this off really quickly, and I want to start talking a little bit more about the other hit result items. So just going over some of them really quickly. The blocking hit and initial overlap, you're not going to use these really ever. The reason mainly being is because the initial overlap is really only if you have two objects that are literally in the same space, the same rotation, everything, but they're just on top of each other. If you get an overlap, and one is eligible to be hit and the other one is not via the trace channels, and we're going to go over that in just a moment. But it's basically you're never going to use it unless you accidentally duplicate a mesh and you don't do anything. So this could be a good way to see if you have duplicates, I guess, maybe. I've never really had that issue, but I guess I could see that being useful there. The blocking hit is the same thing as the return value, so you're never really going to use that. The time function is, again, something that you're not really going to use too much because the time of impact along the trace the trace detection ranging from 0 to 1. If there is a hit, indicating time between start and end equals to 1 if there is no hit. So as far as it goes, it's basically just telling you how long it takes for it to actually detect and hit the item. There's really not, again, a whole lot of reason for that. The vector values here, however, are very, very useful. Location and impact point can be used depending on what you actually need. The location is the hit in world space, and it's basically going to be wherever the line trace stopped. However, the impact point is the same thing. However, it's the trace, or it's the area on the object's face that it's going to go for. So if I do a line trace and it hits right on this edge, this is going to be the impact point is going to be where this face starts. But the trace could start, maybe like a few units in front of it or end a few units in front of it. And that would technically be the location. So if you want something to happen within the world, you doesn't have to be like right up against the item that or object that it hit. You can use location. But if it does have to be precisely on the object, use impact point. Now, when you're putting things on an object, like for example, a decal or something, this is where we start getting into the normals. Now, the normal and impact normal, these are the exact same thing as location and impact point. The only difference is essentially how close it is to the object that it hit. I personally always use the impacts. I don't really use locations or regular normals. I'll use impact. Now, the physics material, Again, not really that useful if you unless you're trying to run some debugging to figure out if you're having any issues with your physics. But you have to have a lot of physics bodies set up to actually make it worthwhile. So I don't really ever use it. But if you do find use for it, cool. But realistically, a lot of the physics material debugging and all of the way that it works is realistically handled a lot by the in-game engine by default. So the hit actor, however, very useful. This allows you to be able to determine certain actor information. So, like for example, if we go out of the hit actor and just like what we did in the interaction, I'm sorry, not interaction, the blueprint interface video where we created the interaction, we can go does implement interface, and this way it'll actually do hit actor, and then we can just select our interface if we had one. But this way it does allow you to be able to do just like what we did before with setting the secondary branch return value, and then we can go out here, multivariable, set to true, and then boom, now we have our actor information. So we can use this if we wanted to for something else. But realistically, we're going to do the information for how to be able to set up an interaction system with a line trace in a separate video, so I don't want to go too much into that. So moving on, the hit component's the same thing as the hit actor. It gives you information. However, hit component doesn't really have a lot of value unless you're, again, just trying to get information about the world around you. But a lot of times when you're interacting with like doors or pick upable items and objects, a lot of time you're going to be using actor-based blueprints just because there's a lot more control within what you can do within the blueprints. However, if you make a component blueprint, you can use this as well if you're trying to get information from that. The hit bone name and bone name, these are also very, very good. I personally use the hit bone name more often than I'll use bone name. It's basically the same thing. The only difference is that if you have one bone on an object, it'll return with bone name. However, if you have multiple, bone name that it's going to return as is going to be root. However, a hit bone name is going to be like if you're trying to get a headshot or make it so that way if it hits the arm, the leg, the chest, different areas of the body will do different damages. You want to make sure the hit bone name is, of a certain value. Hit item, element index, and face index. I don't think I've ever used these in my entire time using Unreal Engine, and I've done quite a lot. So I've never really had any use for these. If you have a lot of overlapping actors, I suppose these would be useful. But colliding with tri-mesh or landscapes, index of the face that was hit, you don't really need to know the index of the face that was hit. The index value of a terrain or tri-mesh landscape is realistically not going to be a lot of use. I mean, I guess if you really wanted to be like, when you're on this section, I want this to happen when you're on this point, but there's so many indexes and so many faces that are within a landscape or a tri-mesh a lot of times, you're not going to really need to get that specific information. Trace start and trace end, however, is literally what we set up here. So it's the actor's location and then whatever the end point is, which would be 250 units from in front of the character. So take a breath. That is what the break hit results is. So that's all these are here. So it's very easy. You can get a lot of information, and you can even use this as branch conditions to set other things based off of what it hits and how it works. Now the biggest thing, and this is going to be the last thing that I want to cover, is going to be trace channels. Trace channels are amazing, and this is something you can use to be able to set up a lot of different functions within your game. So the first thing let's talk about is what is a trace channel and how do you use it? Well, if I go back into the game here and I use my light trace, you'll see that it's interacting with every object in the world. Everything around me, it's allowing me to be able to hit and detect it. However, and that's only because if I select any object here and I go into the collision settings, and if I select under collision presets, let's change it from default to custom. Now you'll see we have trace responses, visibility, and camera. If I go ignore visibility and then click play, nothing happens. It does not detect, and it's like it's not even there. So this is how you control where your traces are actually going to hit and how they're going to respond. So we're going to select that back and make sure that it actually blocks both of these. And what we're going to do now is actually, I'm going to show you how to add your own trace channel so you can make it so that way you can have certain things happen off of certain events and certain, traces happening only on certain objects. So how you do that, we're going to go to Edit, Project Settings. Then once it loads, you're going to go down to under Engine, Collision, and then Trace Channels. So we're just going to click on New Trace Channel, and we'll click on Name and type in test. Default response, you can put this as whatever you would prefer. I like setting it to ignore, and that's only because then I can specifically set the items that I want to for this to interact with, and everything else by default will ignore it. Just makes the whole process a little easier. So now what I can do though is I can set up and go over to this, and now you'll see test is now set up under the collision responses for trace channel or trace responses. So I can go ahead and have it block test, and then go back into my line trace by channel and select under trace channel visibility. I can now set it to test. So now we have our new trace channel doing all the same things that we just did, putting out all the same information, but now instead of using one of the default traces, we're now using a custom one that we've created. So this way it does the exact same things, but it'll ignore everything else in the world. There's nothing else it'll detect other than the objects that we place in and specifically tell it to. So this just gives you some really, really nice control when you're using trace channels. Now, I did say that was going to be the last thing, but I do actually just want to show you guys one last quick thing, and then that will be the end of today's video. So we're going to look at really quickly is just the differences between the line trace and a sphere trace. Now, the sphere trace also operates the same way as the box trace, capsule trace, all that good stuff. It's going to operate the exact same way, so I'm just going to show you one variation. So what we'll do is right-click, and we'll go sphere trace by channel. So we're going to get this one, sphere trace by channel. And then a little tip is if you can hold control, and then while hovering over one of these struct pins here, you can actually drag and drop by holding the left mouse button. And you can hook all these up into a different node. So it's an easy way to be able to rework some nodes. And, you know, if you have, like for this one, how it has, you know, 6 different ones, 3 on each side. Well, this way, rather than disconnecting them and reconnecting them, we can just drag and drop. So now we'll take the trace channel, set it to test. Draw debug type, we're going to set it to for duration. Now, there's one thing on here that is not on the line trace, and that is radius. Radius is essentially, just like it sounds, it's setting the radius for the sphere. So right now it's set to 0, but let's say we set it to a value of 5. Now, if we go ahead and click play, you'll see that there's now a sphere extruding out from the body with a radius of 5 units. So the reason why the line trace versus the sphere trace is useful is the sphere trace, the box trace, the capsule trace, all of these operate just a different shape, operate the same way. So what you could do is, like, let's say, for example, you wanted to get some interactions that are done with a little bit more margin for error. You don't want to have the player be looking at it exactly with a pinpointed line. You know, you want to give them a little bit more room to work with. You can take this radius, we'll set it to a value of something large. We'll set it to like 35. So if I go ahead and click play, you'll see that this is now very big. So I can go and I can be within a large value of that rotation and still be hitting an object. I do not have to be directly on it. And the sphere trace just means that there's an end cap at the end. If you wanted something that's more square with 90-degree angles, you would do the same thing, just set it up as a box trace. So that's the thing that's really, really, really great about the different types of shapes that you can use, is you can use those for different sorts of functions, but they all operate the same way. And again, you know, the trace channels, this is just the basic trace by channel. Now, I will say the main difference between, just to, you know, once again, I apologize, but I'm going to go over this really quick, is if you look, once it hits an object, it goes green and that's it. It's not detecting anything else. So I'm just going to quickly state that if you're looking to have something detect multiple objects within the range of your trace, the only thing that you would change is instead of doing a standard sphere trace by channel, you would just set it to a multi-trace. The multi-trace is essentially the same thing. So multi-sphere trace by channel. So it's literally the same thing. The only difference is that off of the out hits, it's set as a struct pin. So as an array. So we can't break this. We can only do a for each loop with break, and then off of the array element, we can break hit result. So that's how you would do that with this, because it's going to basically take the array information, put it into a loop, and then you can take the hit result. But because it starts off as an array, because you're supposed to be, you're doing this to hit multiple objects, this is what you would have to do. So that is the last and final thing, I promise. I hope you guys enjoyed. I know this video went a little longer than intended, but I wanted to really get in depth about how traces work and the different ways that you can use them. So we are going to be going over some more cool things, some more particular things about the ways you can use line traces within your game and stuff like that in future videos. So I hope you guys stick around. And I just want to also say that I really am happy about, you guys are loving these videos. I've been getting a lot of comments, and I've been watching those viewer counts go up and that subscriber count go up. So I just want to also take a moment to thank you guys so much. All of your support means so much to me. This is what I love to do. I love to design games, and I want to show you guys how you can make your own, as well as so many other things. So I just want to thank you guys for your continued support. And I'm going to keep working hard to try and get as many videos and as many tutorials out as I can. But hit that like and subscribe button if you liked today's video. And as always, guys, stay animated.